Hi, I'm an old guy and I do maths, and today we're going to find the interquartile range of a continuous probability distribution. And here's our function, which describes this distribution. And it's in two parts. Function of x equals 2x, where x is greater than or equal to 0, or less than or equal to 1. And for all other values, y equals 0, function of x equals 0. So let's just draw this so that you've got an idea of what's going on. So here's a very rough outline, and we've got y equals 2x there. And we're interested in the values between 0 and 1. Now, at that point, we have a set of values up here of 1, 2. So if we were to find the area of this little triangle here, it would be the height times the base divided by 2. So the area would equal 1. Surprise, surprise. Our probability distribution should have a maximum area of 1. There is no area between the rest of the function here and the x-axis. This is the only point at which this function rises above the x-axis. These don't exist. This line here exists only between 0, and 1. Okay. So what we're looking for is the interquartile range. And what you'll notice is that the area beneath this line increases as we move to the right. So there's a sort of a skewing effect, if you will, which means that the interquartile range will not be centered around here. It's going to be off to one side. Okay, let's get going. Right, so what do we know? Well, we know that an interquartile range is Q3 minus Q1. That is the 75th minus the 25th quartile. Now we can use calculus to find the points at which a quartile can be found. So let's see how we set that up. So when we're looking for the 25th quartile, what we have to do is we have to find the definite integral of 2x between 0 and some number which I've called x1, which gives us a result of 0.25. Similarly, to find the 75th quartile, we do the same thing. We're looking for a number that I've called x2. These are values along the x-axis. And we need the definite integral of 2x to equal 0.75. Now, the definite integral of 2x is 2x squared over 2, which equals x squared. So let's go to work. Now, I've done one of them here, just so that you can see how this all works. Now, we're looking for area, so we're after absolute values. Area has magnitude. And so what we want is the modulus of x squared between 0 and a certain number to equal 0.25, which means that x1 squared must equal 0.25. So if we take the square root of each side, what we get is that x1 should equal the square root of 0.25, the positive square root, and that is 0.5. Okay, so let's do this for number 2. So what we wind up with is x2 squared is going to equal 0.75. Therefore, the square root of this, which is x number 2, not to be confused with x squared, is equal to the square root of 0.75. Okay, where's the calculator? So this is not, it's not as easy as that. Okay, let's go. So 0.75, square root of that is, I hope you can see that there, 0.8660. 0.8660. Now, the interquartile range is going to equal that minus that. We've found the 2 points on the x-axis. So 0.8660 minus 0.5 is going to give us 0.3660. That is our interquartile range, and that is how you discover it. Okay, so I hope this was useful and helpful. If it was, please like and subscribe, and I'll see you next time. Bye.